Okay, here we're looking at a graph of altitude versus temperature, temperature versus altitude. But the important axis, again, the input variable, is the x-axis, and that's altitude, okay? Right here. This is the x-axis, remember? Because temperature, which is up and down the y-axis, depends on the altitude. Again, think about it, the higher we get, Denver, Mile High, you know, up to Mount Everest, the higher you get, the colder it gets, up to a certain point, okay? So, the higher we get, the colder it gets. And that's what this is saying. So again, as altitude is increasing along the x-axis, can you see that the temperature is falling down the y-axis? It's getting lower down the y-axis as we increase along the x-axis. The higher we get, the lower the temperature. Okay, so now also if you think about this, now what does it mean? This point right in the middle, to me, let's get a pen going, this point right here, this is 0 kilometers high, which means it must be sea level, but it's also 0 degrees centigrade. Now don't get that, it's not that cold at the sea level, is it? So I'm not too sure about this graph. But anyway, okay, so again we are going down in temperature as we increase in altitude. Going along the x-axis is increasing in altitude, but going down the y-axis is decreasing in temperature. And it's going into the negatives. These are negative numbers down here. It's gone below the 0 point, that point right in the middle where I've put the dot. Okay, again, right there. Okay. So we're getting negative temperatures the higher we get, which makes sense. Now, how about going the other way? Okay, so again, if I'm increasing in altitude, I'm dropping the temperature. But if I decrease in altitude, well, what's below 0? It looks to me like we're going underground, okay, into the Earth's core. Now, of course, I think lava gets very hot, the Earth's core, okay? So again, let's get my arrow going. As we're going this way to the left on the x-axis to negative altitude, can you see the temperature is rising, okay, very quickly, okay? So that's what we're looking at here, okay? As we go deeper underground, it gets hotter and hotter. As we get higher and higher and higher, it gets colder and colder. Okay, above that 0 altitude, 0 kilometers. Okay, so, and it looks like the higher we get, okay, so somewhere around about here, at 120 kilometers, starts to get really hot. That must be when you've gone beyond the Earth's atmosphere, way out there into space, okay, it's been bombarded by the sun's radiation. So that's why we get this. That's why this particular graph looks like it is, okay? Now, some questions. Horizontal axis, negative and positives, I've kind of explained that. Horizontal axis has got altitude, that's the important input variable, okay? Here we are, this altitude, what's the temperature, okay? The temperature is just the result of the altitude, okay? So the temperature is like the answer. When I ask, okay, what is it at this height, you say it's this temperature, okay? The temperature depends on the height. Okay, so, again, positive numbers along the x-axis from this little dot in the middle means higher and higher, increasing altitude. Negative numbers means we must be going below sea level, underground. Again, with the y-axis up and down, this vertical, it's in temperature, it's degrees centigrade. Again, positive numbers increasing temperatures. Negative numbers mean we're going below freezing. Okay, it's getting below freezing. Okay, now, it also asks about the tick marks. Can you see I'm going 20, 40, 60, but there are some spaces, there's some little lines in between. So I could say, okay, well here must be 10, here must be 30, here must be 50, here must be, what's that, that's 60, so 70, 80, 90. So can you see that all these little tick marks are 10 kilometers each, okay? Going up and down the y-axis, well you can clearly see it's every 50. 50 temperature, 50, another 50 degrees, another 50 degrees, another 50 degrees, okay? So those tick marks are 50, and these tick marks are 10. Okay, because it just depends on the units. You know, it looks like we've got a lot of degrees C to squeeze in, okay, over a bit less altitude, okay. Look, altitude only goes up to 240, but degree C's got up to 700, so I've kind of fit them all in, haven't I? Okay, right, let's have a look at some other questions on here. How many degrees centigrade? These are the tick marks, and then, you know, where does water boil, at what height? It boils at 100 degrees, looks like there below sea level, underground somewhere, about 10 kilometers below sea level. But also 100, if I go over here, it's also at about 125 kilometers, okay, way out there in space, okay? So that's just a few kind of questions that you have to answer. So I'll do more of that later.